Hello everybody, Elliot Severn here from the Discovery Museum's Henry B. DuPont III Planetarium, and instead of our normal sky tour, we are going to go on a tour of the inner solar system today. Now we're starting out here floating in space, and the first object we're going to fly to is the object at the very center of our solar system. We're going to go take a look at the sun up close. Now, as we fly through space, a thing I want you to note is that all the stars in the background sky are going to appear exactly as they do here on Earth. They're going to make all the same constellations. Nothing in the background sky is going to change because those stars are so far away that no matter where we go within our solar system, none of those stars will appear to move. Now here we are at the sun. It's at the center of our solar system, and its gravity holds all of the planets in orbit. It's a burning ball of hydrogen and helium gas, and its surface is about 10,000 degrees Fahrenheit. It's so massive that about 100 Earths end to end could fit across its equator, and about 1.3 million Earths could fit inside the sun. It has an outer atmosphere as well called the corona, and the corona is only visible from Earth during a total solar eclipse. Although the surface of the sun is 10,000 degrees, which is quite hot, it gets up to millions of degrees within the sun's corona. The sun is spewing out flares and particles. Some of those particles reach the Earth, and we're going to talk about what happens when we get there. There's lots of weather on the sun. As you can see, as we orbit the sun, there are some dark marks across its surface. Those dark marks are called sunspots. They were first discovered by Galileo in Italy, and they are actually cooler areas of the surface of the sun. And in those areas, there are eruptions called solar flares. In order to see the sun in detail, we often have to get above Earth's atmosphere, which blocks a lot of the wavelengths of light that the sun gives off. So a few weeks ago, a sounding rocket carried a spacecraft with a camera that was able to see the surface of the sun in greater detail than we can see from the surface of the Earth. And here's some of those high-resolution images from just above the Earth's atmosphere. Now, many planets are orbiting around the sun. They're split into different groupings. We are going to look at the rocky inner planets today. And the first planet we're going to fly to is the closest planet to the sun, which is Mercury. Here we go. And here we are in orbit around the planet Mercury. And the first thing you will notice is it kind of looks a lot like the moon. It's a rocky body with no atmosphere or oceans, and it's covered in impact craters from asteroids and comets. Mercury is about a third the size of the planet Earth, about twice the size of the moon. It's actually about the same size as Mars, and because it orbits so closely to the sun, it orbits faster than any other planet. Here on Earth, it takes 365 days to orbit the sun once. On Mercury, that only takes 88 days. However, even though it orbits very quickly, it rotates on its axis very slowly. Mercury only rotates once every 176 Earth days. Because Mercury orbits so closely to the Sun, it's difficult to see through telescopes here on Earth because it never gets very high in the sky at nighttime. And so to see Mercury up close, we really need to send space probes there. Now, only 2 spacecraft have ever traveled to Mercury. In 1974 and 1975, the Mariner 10 spacecraft flew by Mercury, and it could only snap about half of its surface each time. As a result, not the entire surface of Mercury was mapped by the Mariner 10 mission. And you can see that there's a bit of a gap on this map of Mariner 10 imagery. And so in 2004, NASA launched the Messenger spacecraft into orbit around Mercury, and it mapped the entire surface. Now, all of these images that you see are actual images from the Messenger spacecraft, starting in 2011 and ending in about 2014. And if we fly in a bit closer, we can load higher resolution imagery from the Messenger spacecraft, and we can check out the craters of Mercury in up-close detail. As you can see, it looks quite a bit like the surface of the Moon. And these are enhanced color images showing the subtle details in its mineral composition. In reality, it's pretty much a black and white planet, just like the Moon is. So we're going to back away from Mercury now, and we're going to head off to the next planet in the solar system, the planet Venus. And here we are at the planet Venus, the second planet from the Sun. It's about the same size as Earth, and it's the hottest planet in the solar system. Now, on Mercury, it has no atmosphere, and so it experiences extremes of temperatures. On the daytime side of Mercury, it gets up to about 800 degrees. On the nighttime side, it gets down to about 280 degrees below zero. On Venus, it has an atmosphere of greenhouse gases, carbon dioxide mostly, and that traps heat from the light of the sun. And so it actually gets up to about 850 degrees Fahrenheit, which is hotter than the planet Mercury, the hottest planet in the solar system. Its entire globe is covered in thick clouds, and so we can't see down to its surface through Earth-based telescopes. And so we've had to send a lot of space probes to explore Venus. Most of the exploration of Venus happened in the 1960s through the 1980s by the Soviet Union. And they sent a series of spacecraft to Venus called the Venera missions. Each one had an orbiter, which orbited around Venus and took camera and radar images. And some of the later Venera missions carried landers, which descended through the atmosphere. And some of them even touched down on the surface. Now, because it's so hot on Venus, and because the atmospheric pressure is so high, even a robot can't last more than 20 minutes to the record of 2 hours. And the Venera 13 mission actually managed to snap pictures on the surface of Venus And these are the best images we have from the ground. It's a very violent planet. In addition to the extreme heat, its atmospheric pressure is so strong it's the equivalent of swimming a kilometer underwater here on Earth. It's covered in active volcanoes and lava flows, and it rains sulfuric acid. And now if we can only see the cloud tops through telescopes, then we needed a way to see what the surface looks like. And so a lot of these spacecraft carried cloud-penetrating radar. And if we look through the atmosphere of Venus, we can see its surface details. I'm going to do that now. So we're taking away the clouds, and this is what the surface looks like. Now, these images were taken by the Magellan spacecraft in 1989 and 1990. And a cool thing about the Magellan spacecraft is it was actually the first interplanetary spacecraft launched by the Space Shuttle. So here's the Magellan spacecraft on top of the inertial upper stage inside the payload bay of Space Shuttle Atlantis. And you can see a worker on the bottom left, which gives a sense of scale. A very large orbiter spacecraft. And here's an image taken by astronauts on board Atlantis just before its deployment. A really cool mission because it's an interplanetary spacecraft that was actually launched by astronauts in Earth orbit. That was on STS-30 in 1989. So we're just going to fly around a little bit and look at these radar images of Venus in more detail. And you can see the hills and valleys. All the bright areas are the low areas. All the dark features are the hilltops and the tops of the volcanoes. We're going to bring back the atmosphere. Now, a really cool thing to witness from Earth is a Venus transit. As Venus goes between the Earth and the Sun, if it lines up just right, you can actually see it passing in front of the Sun. And here's an image that I took of the Venus transit in 2012. Now, unfortunately, it happened twice in 2004 and 2012. It's not going to happen again until the year 2117. So if you grow to be very old, you might get a chance to see the next Venus transit. Now we're going to head off away from the planet Venus to check out the next planet from the Sun, the planet Earth.